overall presentation of the entire solution. We have a layered. The solution is based on a layered architecture. We have the first layer that is on the bottom of the platform of the diagram, that is named the data collection layer, built up by the city data workspace and the IoT device manager. These two components allow us to collect data from the territory, from the environment that we want to supervise and that we want to manage, let's say. The city data workspace in particular allow us to federate resources like legacy systems and open data portals. The IoT device manager, on the other hand, allow us to federate, to register the metadata related to the devices. We are able to support multiple IoT protocols thanks to the FIWARE ecosystem, in particular thanks to the IoT agents. This is just an high-level overview. We will go through each component one by one, both from a description point of view and from a demo, through the demo. The other layer is the data integration and harmonization layer, built up mainly by FIWARE components like the Orion Context Broker, the Perseo Complex 7 processor, and two components provided by us that are the City Data Mashup Editor and the City Mockup Editor. The Orion Context Broker is the tool that contains the context information like the last and most recent measures sensed by the devices or the current status of the data available in the open data portals or in other REST services, legacy systems, for example. Through this component, we are able to decouple all the architecture, and we are able to dispatch this context information all around the platform to the most interested components, like the city dashboard manager or the city data mashup editor, as we will see. The city data mashup editor instead is a component that allows us to harmonize and integrate different data sources into just one complete and more complex data structure. We highly recommend to use the FIWARE data models for this final data structure. Accordingly to this data structure, thanks to Perseo Complex 7 processor, we are able to define rules for triggering notifications both through email or REST API or SMS or something else. The last layer we are interested in is the data visualization layer that takes the data from the Orion Context Broker for the real-time data or directly from the original data source in order to create to be shown on the city front end. Of course, these dashboards are mainly focused to the end user of the city managers. Of course, the most important part of the city enabler is indeed the data visualization layer. Not only the dashboard manager to create a dashboard for city managers, but also, for example, the creation of mobile apps or web apps for final users like citizens. We have also a transversal layer. This is the security layer built up by the Keyrock and the Vilma, mainly composed by FIWARE components. And we have other two layers that are that supports the entire ecosystem, that are the performance monitoring layer for the auto-scaling of the components and the logging layer to log the most important events of the platform. This is a high-level architecture of the platform. Now I will go tool by tool. So the first one is the city data workspace that is located here, as I said, in the data collection layer. In the city data workspace, the city data workspace is a tool intended for businesses and city managers. It is a single point of access to real-time data of the city that are able, and not only real-time, but also static data, made available through different sources like open data, IoT sensors, the historical data of the IoT sensors, or legacy systems, and so on. Into this component, we have already registered all the data source recommended for the open call. Of course, in the next days, if you find other interesting data sources, we can register them on the city data workspace in order to make them available to you for the implementation of your scenarios. The second component is the IoT device manager. It is also in the bottom layer of the architecture, in the data collection layer of the architecture. It's mainly intended for city managers and businesses also. It allows the user to register push and pull sensors in order to make the data of these devices available into the platform. They can be whatever kind of devices. We are able to manage parking devices, illumination devices, pollution, lights, and so on, because this is not a tool verticalized to any kind of vertical. The third tool, and in this way we are switching to the other layer of the architecture, I mean the data integration and harmonization layer, is the data mashup editor. Also, this component is intended for businesses and city managers, but it's an important component. The most important part is that this component requires a little bit of technical skills. It's easy to use, but you must know what you are doing with this component. It allows essentially to create flows starting from one data source or from 2, 3, multiple data sources, integrate them each other, for example, taking the static data from the Open Data Portal and integrate them with the real-time data coming from the devices, and then produce as output a unique data structure that combines both static and real-time data. This is a sample use case. We will do a mashup during the demo later on, but this is just an high-level overview of the component. In the end, when you will create the fiber data model, you can use this data for creating a complex dashboard, simple or complex dashboard, following a self-service approach. I mean, you can create, you can start from scratch, from a totally empty space, and there you can put both charts, maps, images, HTML snippet. You are totally free to create a dashboard with the layout you want. In the end, once you have created the dashboard, you can export this dashboard to a third party. Let's say it's always inside the platform, of course, a component that is named the city front end, where the dashboard will be made available to everyone, to city managers, to businesses, to citizens, and so on. This is just a consultation site that will be totally available for everyone. So this is a high-level overview of the tools that most probably you will have to deal with. And now I'd like to go to the live demo of the platform. Do you have questions so far? Okay, perfect. So I'll start my presentation of the platform. So going to digitalenabler.eng.it, you will have the possibility to access the showcase of the platform, where you have a complete overview, even deeper overview than the one that I did so far, of the components of the platform. Here you have the city front end, the dashboard manager, the city data workspace, the IoT device manager. By clicking on each of them, you can go directly to the component you want to visit. So this is the main entry point of the platform. Exactly. So let's start from the city data workspace. This is the main page of the city data workspace. As you can see, you can log in, but it's not mandatory, because you can navigate the tool also as guest. Here you can search over 9,627 datasets made available from 35 catalogs registered in the city data workspace. We have the tag cloud, and this is the list of the data source already federated. We have the open data portal of Helsinki. We have a geolocalized air quality feed. This is a REST API. It's a private institute that exposes air quality data for many cities all around the world. The same for Open Weather Map. These are the REST API that we natively expose with the digital enabler. We have the open data portal named the LIN, that is for Antwerp use case. Also this one, many of them are from Antwerp. There is also the Antwerp GeoPortal, the city in Cyprus, the open data portal of Antwerp, the Belgium open data portal, the Flanders open data portal, and so on. And then we have also the real-time data for noise level in Helsinki. It is this tool here. We have the history of the noise level in Helsinki, the air quality in Helsinki also. By doing this show source, you can go directly to the endpoint. Of course, this is just an endpoint. You have to configure the API key. In this case, you can find other direction, other instruction directly by clicking on the open data instructions, of course, in this specific case. And we have the HSY in Helsinki, the SDK for tourism, the list of civic issues in Helsinki, and a lot of other data. We have the OpenStreetMap data already available, the historical air quality data in Helsinki also, and other CAPTA HSY in Helsinki also. So all of these are data that you can exploit just now for your use cases, for your applications. But of course, here I repeat, if you find other interesting data sources, you should find other data sources. You can report them to us, and we can add them to this component. One interesting feature of the city data workspace is that we can also start, for example, let's start the research to all the data sets. And as you can see here, we provide natively an evaluation of many open data. For example, this Flanders, this data set from the Flanders open data is evaluated as lacking, and by clicking on the lacking, you can see the reason why this data set is evaluated like lacking. Many others we have many others data sources. Somewhere we should have also the Helsinki open data. You could also select example from here, Helsinki. Okay, also this one is lacking due to the update frequency, so they are not frequently updated data sources, but nevertheless you can use them, of course, for your use cases. So I would like to go in this moment. I would like to show you instead the City Data Mashup editor. The City Data Mashup editor is available at mashups.digitalenabler.10.it. We have an instance here. To access the City Data Mashup editor, you must have an account because it's a closed and open component, and here you can register, you can import data sources this way, create data source. Here you can define a title, a description, an endpoint, the HTML, the HTTP method, get, post, put, patch, and delete, and the URL you want to invoke in this case. You can import the resources directly from the City Data workspace. You can trigger a research by keyword. The data sources that are not importable, doesn't contain importable resources, are marked with this icon, attention icon, but you have some of them that are importable. For example, this one, this is an XML. For example, you have this one that is also an XML. Or otherwise, you can import a service, a REST service from a descriptor. So you can import a WADL file or Swagger file through a URL or from a file. And also in this case, you have to select the type. Once you import a data source onto the City Data Mashup editor, you will have it in your data source list. Here I have a lot of data source that I used for many use cases. And for example, I will show you in the next minutes during the demo, I will show you the usage of this one. That is the air quality feed, and also the open weather map, this one. The other part of the City Data Mashup editor is the project management. So you can create mashup projects going to the mashup projects page. That is this one. Here you can create a new mashup, and you are prompted with create a new project, where you can select a name. You can define a work group. Thanks to the work group, you can share the project with the other users. You can define a description. You can find the space where write the description, and you can select which should be the output of the mashup. This part of the task settings I will explain it later on, and also the targets. So now let's create a mashup. Let's call webinar 010219. Choose a work group, demo mashup for webinar. Okay, nothing else is required, and we can create the project. This is the project here. By clicking on the pencil, we can open the working area of the mashup. This is the most critical part of the flow of the entire platform, because here you can get the data from a data source, an external data source that could be a resource on the an open data portal or on a REST API, or can be also the data coming from the devices. And you can integrate this data, as I said before, to create a new complex data structure and harmonize everything accordingly to some data structure that you want to use in the dashboard manager or in your own application. So first of all, in this case, let's suppose that we want to create a mashup that takes the weather data for a specific city, and we want to harmonize it accordingly to a fireware data model. So first of all, we simply drag and drop the current weather data source, that is this one, the white block, onto the working area. We have a single input. In this case, we can change the name, city ID. And say we provide the city ID as input to the service, and here you can find on the right side of the model, you can find the input expected by the service. In this case, the service is documented here. You have the documentation on the help page, is this one. As you can see, the parameters are the units, the app ID, and the ID, that is actually the city ID. The city ID is available directly on the site of Open Weather Map. It's a resource that you can download from the portal of openweathermap.org. I think I already have it somewhere. One moment. I should have it somewhere. Let's open another shop. Helsinki ID, this one. This is the ID that I found on the Open Weather Map website. So nothing specific to the platform, it's just for the Open Weather migration. Okay, the city ID is this one. This ID is Helsinki, the Helsinki city ID. And we want to use this ID as constant. It means that to each invocation of the mashup, I won't be asked to put this value inside the request to the mashup. I simply connect the input to the service, and I drag and drop the city ID to the input ID of the service. You have also online documentation where it is available, for example here, city ID. And you can find here many, in this case, we have some constants also available to the, also already registered into the data source. For example, in this case, we can use the metric unit system, and this is the app ID. Let's connect the current weather service to the output. Let's save and preview. Okay. Okay, this is the result of the invocation. This is the output of the Open Weather Map API, REST API, that I can obtain by simply providing the city ID of Helsinki to the REST API itself. So in this case, I have the name Helsinki, the ID as an echo, just for confirmation. We have the cloud. We have information about the wind. We have information about the temperature, the pressure, the humidity, the visibility, and an overall description of the weather conditions in the city of Helsinki. This is just the output of the Open Weather Map API. Now, what we want to do is, in this case, to harmonize this data structure to a more simple, a simpler data structure based on the fireware data models. What are the fireware data models? The fireware data models are a data structure defined in the fireware ecosystem, fireware data models, this one, for many use cases, for many verticals. On the website of fireware, you have different data models for many use cases. For example, for building use cases, for alerts, civic issues, devices, for the use case of the environment, other fireware data models for indicators, for parkings, and many others. What we are interested in this case is the context of the weather, and we want to harmonize everything accordingly to the weather observed fireware data model. That is this one. At the bottom of the page, we have an example. This will be the output of our mashup. Okay, with these fields. We have a native on the city data mashup editor. We have an already present operator, a native operator named the weather observed under the fireware section here. What we have to do is just connect the output of the service to the fireware data model connector operator, and we have only to drag and drop the fields to populate on the right side the fields of the fireware data model. So, for example, the ID obtained by the Open Weather Map API can be the ID, the unique identifier of the fireware data model in this case. The date created and the date modified are automatically populated by the Mashup editor. We can populate the name with the name on the left, the date observed. Let's say if we have something similar. I think no. In this case, we don't have it. The location. The location expects, accordingly to the fireware data model, the location field must be a GeoJSON. Here we don't have a GeoJSON, but we have the coordinates. So we can create a GeoJSON starting from these two fields. How can we do it? Let's put OK here. And at the bottom of the fireware section, we have a point operator. This operator receives in input the coordinates, latitude here, and longitude here. Let's check what happens in this case. And we can connect the point to the weather observed. This is the GeoJSON primitive that we created thanks to the operator by simply dragging and dropping it on the working area without writing anything, without creating a complex object and so on. So we drag and drop the entire object with the dollar onto the location field. And that's all. Now we can continue the mapping of the tools, of the fields, excuse me, the mapping of the fields from the REST API to the weather observed. We double click on the arrow and we can continue the mapping. We can select the source, for example. Do we have something? It seems no. Okay, so no source in this case. The weather type is a field. There is also a description. The observed weather type. So, for example, cloud, partially cloud, mist, and so on. And we can take this information from here, from the array weather. The first object is weather of 0. We can take the description and we can drag and drop the description onto the weather type. The temperature, we have this information in the main object. The relative humidity we have also. The wind direction and the wind speed. We have the speed and we have the direction in degrees. We could populate also the solar radiation, the pressure tendency, the barometric pressure, and so on, but we don't have this information from this REST API. If you find some other data source where this information are available, you can invoke this other potential hypothetic API, and you can connect directly to the same operator, to the same fireware data model operator, in order to enrich the final result. Okay, let's save everything and we can preview everything. As you can see, we have a standardized data structure obtained starting from a completely different JSON, serialized with information serialized in a completely different JSON to a fireware data model compliant data structure. Of course, the fireware data model data structure is the one that we highly recommend for the integration and for the reusability of the mashups. But of course, if you want to use another kind of data structure, you want to use your own data structure, you are totally free to create it with a plethora of operators that allow you to create and manipulate objects, create arrays and manipulate them, manipulate strings, do something and mash up objects, array, and so on, create object. And you have also other advanced operators that allow you to manipulate CSV data, JSON data, XML data. You can stringify objects, you can create simple mathematical formulas, and so on. This is a very simple mashup. As you can see, we have one input, one REST service, we invoke an API, we change the data structure, and we return everything as output. Question so far? Okay. Let's create now another more complex mashup. In this case, we want to start from the city name, for example, Helsinki, always Helsinki, and we want to obtain the air quality data for the city of Helsinki. To do this, we want to use the API provided by this service, API Air Quality Index. Here you have the search API that starts from a keyword and will return you the list of weather station, of air pollution station that matches that keyword. We can use it to create fiber data models for the air quality. Let's create another mashup. So air quality mashup webinar 01/02/19. Select the workgroup and the description: air quality harmonization of air quality data in Helsinki. Let's create the project. Okay, let's open this. Let's edit and let's go to the working area. In this case, we import the service named Air Quality Index Search. This wants a token and a keyword. The token is embedded, is already available in the service. We can connect the input to the keyword field and connect the output of the REST API to the output of the mashup. Here we have the city name and write Helsinki as constant. Save, preview. Okay, this is the output of the API. We have 4 stations all around Helsinki. The first one is named Helsinki. The second one is named Kallio 2. The third one is Vajila 1, and this one. Okay, so what you can see, as you can see here, now we don't have a single object to harmonize, but we have an array of objects. So we have to harmonize all of them. All of them. Let's open that. Let's take a look at the object. The objects of the request. Token and keyword. Keyword equal key and token equal this one. Okay, as you can see, this is the output of the Air Quality Index API that is totally compatible with the one that we have here. Status and data, and so on. We have to harmonize every single object into a fiber data model. Let's go back to the fiber data model page and let's search something for air quality. We have air quality observed, and this is the data structure. So we want to obtain something like that. Okay, first of all, we have to say to the mashup, okay, let's iterate over the array that contains the array named data that contains all the stations. And then let's harmonize everything accordingly to the 5 data model. What we can do is embed an iterator operator that receives, this is important, receives only strings. So you have first to stringify the array. So let's take the data and then connect the array of strings, as you can see, to the iterator. What we can do here is to connect another mashup to the iterator. We have to say, okay, for each entry of this array, you have to invoke this other mashup. Which is this mashup? We have to create it. So let's go to projects, mashup projects, and the new mashup project. So let's call it inner air quality webinar. Okay, always the same digital enabler workgroup, and create project. For this one, edit. The input of this mashup will be one entry of this one. For example, this. So let's write the default value that we use as a sample for the creation of our mashup, and we can call it, for example, JSON. This is not a constant, of course, because for each iteration we have different values. We can transform the JSON to an object. Okay. And we can connect to the hood. The preview show me just the one entry of the one I obtained here. So if I open the first one, UED 5717, and here we have just one of them. For each iteration, in the second iteration, it will put into the JSON input, this one. In this input, we will have the second entry. In the third iteration, we will have the third entry, and so on. So once we have the JSON object, let's inspect it. Let's inspect him to see what we can do with it. We have the station name and the coordinates, but we don't have the air quality relevation. In order to obtain them, we can use this other service that receives the coordinates as input and the token, of course. We have this structure and we have one single field. In the documentation, you can read how to serialize it. Geo coordinates serialized as follows: geo column 0, the first coordinate, the two coordinates, let's say. Okay, so first of all, we have to concatenate the coordinates to obtain the intended string. Okay, so the first one is the geo0, the separator is the column, and the second one is this one. Let's save it. The documentation says that it should have also a geo column prefix. So let's put this prefix as a constant in this case. And we concatenate the first output with the other constant. Okay, now we have the intended string serialization for the geo. Save and preview. Preview. As you can see, we have the data, the attributions, we have the data for the city, we have the pollutant, in this case NO2, O3, PM10, PM2.5, SO2, and other ones that I don't know the meaning of this one. So, okay, now we have the air quality data that we can harmonize. We decided to harmonize everything accordingly to the air quality observed fiber data model. So we will connect, no, we will connect the output of the feed coordinates with the input of the air quality observed fiber data model. We will use the ID X ID. We have, as before, we have to create the GeoJSON starting from the two coordinates, but we will do it in a while. First, we will populate other fields, like for example, the source that we have somewhere. We have somewhere, for example, here, URL. Let's put the source. We can the name. Somewhere is the name. There is the name, so address. And an overall air quality index, that is this one, AQI. Perfect. We can put all the pollutants. We can create a custom NGSI attribute to be merged with this one. So say this flow so far. Preview. And we have the fiber data model without pollutants so far. So what we can do now is to create, always in the fiber area, we have the NGSI attribute. Let's create an NGSI attribute starting from, for example, the NO2 value. Let's put the value here. We have to put also the name and the type. So let's create two constants. So NO2, and we put NO2 as value, as constant. and this will be the name. And let's create another field, custom constant field, that is the number with the value of number, and this will be the type. Okay, save. Let's do the preview. No, something wrong. Let's refresh. We should have only one output here, so let's first merge the two objects. We can do this. Okay, add a new object. We have to merge the object containing only the NO2 attribute with the base fiber data model. Add a new object, and we can add the entire fiber data model. And this will be the overall output of the mashup. So the ID, the air quality index, the date modified is populated by default automatically, the source, the address, and the type, and the NO2 attribute that we manually added to the data structure. Let's add just another pollutant, GSI attribute as well. Let's put the PM10. Also, this one is a number. So let's do this just for readability. Okay. Number. And another input. That is PM10. The value is PM10. A constant, also this one. And we can connect it to the NGSI attribute. And this is the name. Also, this will be merged in the final output of the mashup as a new object. This one. Okay. Save and preview. And now we have also the PM10 value in the same data structure. So this is the mashup that starts from this information, starts from the information about the station and obtain as output the air quality data harmonized in fiber data model. Coming back to the outer mashup, let's refresh in order to make it aware of the presence of the other mashup. We stringified everything. Now we said we have to iterate over the stations. We connect this way. This is the array. And we invoke an inner process that is the red blocks, the inner air quality webinar. Let's drag and drop everything, the first item as a sample. And we can connect the iterator to the output. Wait, I'm connecting the plug. Okay. Perfect. Let's do the preview. Now it starts from a name. The name, the string Helsinki. So we provide an input that is Helsinki, and automatically we obtain the air quality index and the pollutant for NO2 and PM10 obtained by the 4 air quality stations all around Helsinki. If I change the city name, for example, Antwerp, say, let's try it. Let's see what happens with Antwerp. We have 6 weather stations in Antwerp. The address is Antwerpen, Belgium, and we have also in this case PM10 and NO2, but the data are in 6 weather stations. The same we can do with different cities. We can simply change the default value of the city, or we can invoke this API directly with an input, a specific input. An important thing that I would like to highlight is that the output of the iterator is an array, and this is okay, but we have one more object. We have a fuse 046 that is not as expected. We expect just one level, so an array of objects, and that's it. In order to extract this object, we can extract the property. So connect the output of the iterator. The source array is the entire array, and we want to discard the fuse 046 object, and we want to decrease the level of nesting of the final array. The struct property is the new output of the mashup, and that's it. And that's it. Now we don't have any more the fuse 046 element, but we have only an array of objects, and that's it. And this is what we want to do. Now, this data can be invoked in 2 different ways. The first way is to directly invoke the mashup by using an API that is automatically exposed by the mashup editor thanks to the ID of the mashup. But this is not the most recommended way, because for each invocation, the mashup executes the entire flow, and this could take many seconds, many minutes, depending on the amount of data it has to manipulate. Also, in some cases, also hours. So this is not the case. It's not the best way. The approach we recommend is to publish all the results of the city data mashup, of the mashups, into the Orion Contest Broker. In order to publish everything on the Orion Contest Broker, we have to go out of the Mashup, and we have to address that. We have to go to the edit project info, and we have to go to targets. What is a target for a mashup? A target of a mashup is a listener, let's say. Every time a mashup is published, is executed, the result of the mashup is published somewhere. Where is this somewhere? We have two different types of target. We have the Orion type, and we have a custom type. A custom type is an endpoint and an HTTP method, so we can post, patch, or put the output of the mashup via HTTP to some REST API somewhere. In this case, we want to use the Orion Contest Broker. The digital enabler, the city enabler, provides a default Orion Contest Broker. Let's call it default Orion Contest Broker. Whose endpoint is HTTP GB digital enabler v2 entities. This one. I don't know if you have confidence with the Orion Contest Broker, but to publish everything on the Orion Contest Broker, we have to provide two headers that are file service with a value, let's say webinar demo, and a firewall service path, let's say slash, the trailing slash is mandatory, webinar demo, webinar demo. Okay, add header. You can provide authorization or how to authorization, keystone or keylock authorization, and you can define execution rules for this listener, for this target. So you can say always, every time the mashup is executed, everything is published to the target, or never, just to, let's say, pause or stop the target without removing it. And ruled. Ruled means to apply some rule to the output body. For example, if the NO2 property is greater than something, you can trigger this target. Otherwise, it's not decided. So let's leave always, and let's add this target. The target goes here. Switch back to project and save everything. Now, let's analyze also the task settings part. Task settings is very simple because it simply means execute this mashup every X seconds. For example, every 10 minutes, that is 6 seconds, associated task. So every 10 minutes, in this case, the mashup is automatically executed, and the final output of the mashup is published onto the contest broker. Of course, if we go back to the mashup project, we can start the task. The task is started. It requires some seconds. In the meantime, we can open up Postman to go to check the availability of this information to the contest, into the contest broker. Okay, so I have some. Okay, this one. No cache, and I have a preset. So fireware service is webinar demo, and the fireware service path is /webinar demo. Send. We have the results, all the results of the mashup for Antwerp, as you can see, accordingly to the fireware data models, to the air quality observed at the fireware data model. We can use this information to populate a dashboard, to populate an application, a mobile application, a web application, and so on. Why we decided to use the air quality observed data structure? Because this is a standard de facto for smart cities. We have the possibility to reuse this mashup by simply providing the same input and obtaining the same output. So with this data structure, allow us to reuse the mashup, allow us to reuse the dashboards, will allow us to reuse the web application and mobile application. There is something wrong in this case. Let's do it. So. And how to have this one, it's wrong. Yeah. Okay. Good. Do you have some questions so far? I think no. Okay, I'm removing some wrong information. Okay, and we have also, okay, this is correct. This is wrong as well. Okay. This is correct. Perfect. So if I get it, now everything is good. Okay, now we can switch to the dashboard manager in order to import this real-time data for creating our dashboards. I'm connecting with an administration account. Let's switch to the dataset manager. And let's create a new dataset. So webinar Helsinki air quality. Webinar air quality, and enough. The name, description is the same, it doesn't matter. And the price, I read the default one. Type. It is a REST dataset. As you can see here, you can import many different type of dataset. You can create your dashboards on top of files, on top of database queries, on top of Java classes, script written in JavaScript or Groovy, on flat dataset, SQL resources, SparkQL, endpoint, REST API, we are going to show this one, and Solar Cache servers. Let's select the REST dataset type, and let's put the information for this dataset. So this is the endpoint. Okay. Let's put some additional query parameters that are specific for the Orion Context Broker. With the pattern is .star. It means all the IDs without distinguishing the type, and the type is air quality observed. This allows us to select, starting from this context, webinar demo, allow us to select only some entities, only the air quality observed one, because with other mashups we can push inside the same context webinar demo, we can push other types of entities, and thanks to this query parameter, we can select only one or the other one's entities. The method is get. We select that the file service here. We say the webinar demo, and the file service / webinar demo. We select NGSI, we save, and preview. And we have the air quality observed entities we created with the mashup. Close. We can say, thanks to this fields metadata model, we can say that oh, I forgot the location. So let's go back here to the mashup. Okay. And let's go here and select the point. Let's create a point starting from the city data, this one. Latitude and longitude. Okay, and we can connect this here. We have the JSON here. Okay, and let's save. Just to make you aware of the difference, I'm going to add another target for this. So let's stop it. And let's publish it to another context. For example, in webinar demo 2, add target and save project. And let's play again. Webinar demo 2. Okay, now we have the location here. Most probably we will have the same problem of the NO2. Yes. So let's remove the spurious one. to this one, and not this, but this one. Okay. So now we can go back here. We can change so let's go here. Okay, it's correct. Save and preview. And that's okay. So now we can go to the fields metadata, and we can say that the location is a spatial attribute, the NO2 is a measure, the PM10 is a measure, and the air quality index is a measure as well. All the other fields are simple attributes. This will be useful in the dashboard creation later on. So let's close the dataset and let's switch to the dashboard creation. So we can go to the home here, and we can select the dashboard management, and let's create a dashboard. You have a totally empty space where you can add widgets. What kind of widgets you can add to the dashboard? You can add the texts, you can add images, charts, HTML snippets, tables, maps, and many others. For example, we have georeferenced information, so let's show this information on the map. Which are the layers of this widget? What kind of information we want to show? So let's select it from here. The name was webinar air quality. Let's select and add. Let's go to the metadata. The location is a GeoJSON. It's not a simple string. And we want to show directly on the map the air quality index. Instead, on the details info window for each marker, we want to show all the informations, the date modified, and the address. Enough. Let's go this way. And here we have the 4 points. If you click, you have all the informations obtained from the REST API of the air quality index. Of course, if the data changes on the air quality index, this information will change in real time directly on the dashboard. You can also style a little bit your map. You can remove the title, or you can say, okay, for example, air quality stations in Antwerp. You can change the borders, the shadow, the extra large, and the background color. For example, this way. And you have all the information you need. Save it. Antwerp air quality. Okay. And we have Antwerp air quality. You will have this information in your own folder with your name. This is the visualization of the dashboard. We have only one map so far, but we can, of course, change everything. For example, we want to show also the information on a chart. by selecting the same data set, but we can also add other data sets in the same dashboard. Cancel, excuse me. Okay. What kind of chart do you want to show in this dashboard? In this dashboard, you want to show, for example, a line chart, a bar chart, excuse me, with on the x-axis the ID of the station, and on the y-axis the NO2 and the PM10 details for each station. Let's show the legend as well. Show legend without a title and save. Something wrong? Let's try only with one. Okay, now let's add the other one. Okay, that's correct. So this is the chart, and in this case, we can remove, for example, the title. But we want always the same background and the same shadow. Excellent. Save. Perfect. Another interesting feature in this case is that we can, for example, write HTML snippet with placeholders like this one, where we can select many data coming from data sets. So we can select the data set we want to show, and we can arrange the best user interface as possible. For example, we want to show all the air quality indexes, or yes, for example, this one. Not this, I forgot the code. So edit, and in this case, for example, KN repeat, limit 4, true. So let's do this one, it's better. For example, the column name is air quality index, and the row number is 0. So we want to show only the first one, the first air quality index. We want to show everything in an H1 tab, or better in an H3, H1, H1, the air quality index in, for example, we want to show only the first one in the address, line 0. And that's it. Okay, so is this one. Of course, you can play a little bit with the CSS and with a better, let's say, HTML serialization of the information, but this is a very good proof of concept in this case. Let's remove the title, and let's put the shadows also in this one. Perfect. Let's save. Okay, now that we have the dashboard ready, we should import it in the city front end to make it available to the city managers, for example. In order to do this, we have first to publish this dashboard to the shared S4C folder. Currently, this dashboard is only in my own personal folder. So the Digital Enabler Admin is my personal folder, and I want to switch the position of this dashboard to the S4C folder that is a public folder. So let's deselect this one and let's select this. Done. So now I don't have it anymore here, but it's here, Antwerp Air Quality. Now, coming back to the main page, let's open up the front end. Let's open the city enabler. And for example, in Antwerp, we have an already existing environment dashboard, but we can add another one. And we want to import the Antwerp Air Quality dashboard. Let's add it and select it. Let's change the dashboard again. Some problem with the roles. Okay. Just to have an overview of the possibility of the possible dashboards that you can create, because we already created them. For example, in Helsinki, we have already created dashboards, environmental dashboards, like this one. With the air quality, with the weather conditions. So here we have a heat map. If you click on it, you have the details of each station, air quality stations, that like we did so far. We have the weather conditions, barometric pressures, and so on. And we have also the noise level detected in some point of the city, detected by the sensors. Moreover, we have the possibility to define KPIs. This is another kind of chart. Helsinki corruption, the crime levels, the corruption level, KPIs for transportation. They are very simple, but really impressive visualization, data visualization. So now we have completed the entire flow, starting from the data source import to the data visualization. I would like to know if you have questions.